In this video, we're going to have another example of a one-way ANOVA in Excel. Now, this problem will be slightly different. For this one, we'll be using baseball statistics, and we will go on and do that second step that I talked about that we didn't have to do last time because we didn't have statistically significant differences in the means between groups. So I took an econometrics course in undergrad, and it's basically applied stats for economists. In that class, we focus on sports. And the professor said one of the reasons why he did it, the main reason is that the data is really rich and really easy to obtain. So often in statistics and in some places in their econometrics courses, they focus on sports to be able to use really good data. Now, I'm not a baseball guy, but I did grow up in the Homo Little League World Series. So I guess I should be and have more baseball knowledge. I just have the sort of basics. But here we have the positions on the baseball team. We have a few of them. It doesn't look like we have like anything in the outfield. Um, Now notice that we don't have names for the players. We have individual observations, but we just have their position and their batting average. For some of you, for your final project, you may have to work with data without individual names. Don't worry about that at all. That's very common. Anytime I work with individual level data, I don't have names attached to those, like when I do this in my own work. So very, very common. It's the norm. It's probably more rare to actually have the names attached, and it's not something you would work with. So our basic question here is, do baseball batting averages differ by position? We'll be ignoring the second question for now. So do these batting averages differ by position? So for our null hypothesis, that would be that there are no differences in batting averages among the different positions. The alternative hypothesis would be that there are differences. So our first step is to get our groups together so we can calculate the mean for each position like we've been doing. So we can go take both columns and we can sort by position. So now we have catcher together, first base, all those positions together. So we can create new columns, which would be the observations for each category, each position. So we can do catcher here, first base, pitcher, second base, shortstop, third base, and I think, yeah, we stop at third base. Okay, so we just copy and paste the data in for each one. So we'll take all of the catcher, and we can just do normal paste here because these are values. There's no formula associated with it. And you see we have a situation where we have a different number of observations for each category. Not a big deal, not something that we have to worry about. Right, so now that we have the data in here, we'll select the data analysis tab, go to the data tab, and then select data analysis from there. We're going to select ANOVA single factor again, like we were working with last time. So now for the input range, okay, so we have labels in the first row selected, which is good. So now let's just go to the input range and we'll go down, make sure to include all of the data. Shortstop has the most observations, make sure to include that. Doesn't matter that there's blank spaces there. Excel knows that and they can read it, thankfully. We'll leave alpha at 0.05 and their output range. That's fine. We'll move it down a little bit just to make it easier to see. And that spits out our results. So the output display displays the statistics by the position up here. So we have the summary. So for each position, we have the count, we have the sum, which for batting average doesn't matter, but we have the average of batting averages by position, and we have the variance by position. Um, So yeah, our F statistic down here is 5.44. Looking at the p-values, we see it's 0.0005, way less than 0.05. So this tells us that we will reject the null hypothesis, going instead with the alternative hypothesis. Basically, what that's saying is that there are differences among these means across positions. That's all it can tell us right now. It tells us there is a difference. It doesn't tell us where the differences are. Now we can visually inspect this, go down to the average category, highlight that to keep it. You see pitcher is much lower than the other positions. It's under 200 batting average. That's the only one under there. If you know baseball, you know that's pretty common for pitchers to not be the best hitters. For every Babe Ruth out there who was a pitcher early in his career. Well, in the American League, right? Yeah, the American League, they have designated hitters, so the pitcher doesn't even normally pitch. So not surprising to see that. But um, we can actually go and look at where those differences are. So we don't have to like judge with our eyeballs. That's what statistics is all about. So to do that, we can use the Scheffe post hoc test. I really hope I'm pronouncing that right. So for that, rather than using something from data analysis or something within Excel, we can use a macro. There is a macro on the module page that you can download. Just like last time, if there's an issue, you can go into look at it in the folder, right click it so you go to the properties and then check the box to like, there's something at the bottom that's like allow you to use or stop blocking or something like that. So let me pull that up right now. And this is what the file looks like once you allow yourself to edit it and things like that. So in this column right here, we have the means for our various groups. Well, let's say right here we have start with the desired alpha level, and then we have the mean squared error within from ANOVA. So the means here, and then the mean squared error we're going to have to get from the previous sheet. 0.05, we can decide to put any number in there. 0.05, remember, is the most common. We can go 0.01 if we want to be a little bit more accurate. But don't go putting random numbers in there. So pull from here, the mean squared error from within groups is down here. So we can paste that in there and then get the means from each group. So copy those, and those are values again, so we can paste them in there and not be worried about that. Okay, so we also have to do the sample sizes in the next one for each one. So go to the count here. That will be our sample size. And yeah, just copy and paste that in. And there we go. Automatically spits out the results for us. How cool is that? So basically what this does is we have the lower level and the upper level of a 95% confidence interval. We have 0.05. Under the sign column here, it displays significant if there is a statistically significant difference. So if the p-value is less than 0.05. So hopefully this doesn't look too scary. The reason why, so this is group 1, group 2, group 3, 4, 5, and 6. The reason why we get fewer each time is that it doesn't double count. So right here, this is blank because this is comparing group 1 to group 1. Obviously, it's itself. You're not going to get that. Here for group 2, it's blank for comparing group 2 to group 1. The reason is because we have group 2 to group 1 right here. And then, of course, 2 to 2, that's 2 to itself. Here for 3, 1 and 2. Well, 1 compared to 3 is here. 2 compared to 3 is here. So we've already got that spit out. So this is, each time it just does the unique ones. So it goes down fewer and fewer. So what do we see? Well, statistically significant right here, a difference between group 1 and group 3. Let me go back to that and we can copy and paste our groups in there, make it easier to read. Oops. Okay, so I guess that there's some formula in there. Oh, there's the group name there. Okay, so group 3 is the pitcher. I'll put that in red real quick to highlight that. Remember, the pitcher was the mean much lower than the other ones, which are about 0.25, 0.23, 0.26, 0.25, 0.25. So they're all about the same. Visually, we said there's something different with the pitcher. Well, we see here group one and three, not group two and three, but then group three and group four, group five and group six. So the pitcher is different from catcher, second base, shortstop, and third base. And notice the first base is 0.23. That's the closest one to the pitcher, and that's not significant. So basically, what we did, the first test, the ANOVA, allows us to see if there's a difference anywhere. That's the important part of that analysis. For this analysis, the Scheffe test, it's telling us where the difference is. So if you find that there's a statistically significant difference from your ANOVA test, that's when you step up, you do the Scheffe post hoc test and see exactly where that difference is.